Welcome to the Lowest Cast Podcast, episode 23. Let's go with that. Yeah, I found something. There's a cipher here. Okay. Anyways, you go from O to 4 to V to 13. And then you have to go 15 above it, 22 above it, and 41 above it. I guess it's not all written here. The 45th letter of the alphabet is capital O. The 22nd letter is V. The 15th letter is lowercase o. V. 41st letter, capital O. Capital O, lowercase v, lowercase o, capital V, capital O. And there's no 13 in there right now. So that's a little thing I have going for me. So let's just take a look here. Okay. So we did the, little cipher decode one way and looked at it, right? That was fun. And then this is the one I did. So I tried it again, and what I did was pretty much the same. Let's try red. So I started at the beginning. Okay, and I was looking at this column, and I started here after my assumptions, and it's, right, 13 plus 15, it's like the one before it and something. Okay, and then the next one's the one before it and something. The next one is the one before it and something. See what's happening? You're going up by 15. By 22, and by 41. To find your 28, your 50, your 91. Your 110 is the one before it plus 19, and if you look at these three, reduced, that's a 10. No, these three, sorry. 110 is equal to the one before it plus 19, which are these three, reduced. 10, 4, and 5, if 0 is actually nothing, is 19. So 19 plus 91 plus 19 is 110 here. So we have, again, there's a 13 kind of in the seam, where it should be. Then you're going up by 15, which is O. Then by 22, which is V, and then by 41, which is capital O. No, OVO, VO, OVO, VO. Wow, OVO, VO, because it's a big one. Wow, wow. Anyway, OV's a good beer if you're a, aged Quebecer. Yeah. And then your 340s here, but there's another thing. I forgot. Do I have it better? Should I just do it again? I'll just do it again. Look, it's very simple, people. You got your... Right? Alright, it's all there. What do you mean, Kevin? What do I mean? Alright, Oh yeah, that's what I mean. Okay, again. This jump here is 41. This jump here is 22. And this jump here is 15. Okay? 15 is your letter O. Or is it the 6 and the 9 of balance? Is the 6 and the 9 an O? And then this circled O mean a capital O? And is that another lowercase o? And this is not, I would say, an O. But that looks like a 41. And that looks like a 22. So if you have the 22... you have the 41, and you definitely have an O somewhere. Okay. Where's your 110? Well, it's right here. Where's your 340? Oh, it's right here. 3, 4, 0. Hmm. 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 So, right here. I didn't say these were good. It is a capital O. 41 is a capital O. Remember, 41 is a capital O. Okay, I was again going from the seam, linking these two, linking these two, linking these two, finding my little theorems. And then I looked over here and I said, okay, why? Okay, and then I looked over here at the bubble math. Okay, I did some, like, there's your 110. Anyway, I don't know if this is right, but I was thinking in terms of bubbles, how to get the 15, the 22, and the 41 by bubble math. But I digress. And this was important, and this was important, okay? And the reason that this is important is because, again, we are going from... I think I understand also why I add 16 over here. I understand this 16 now. Okay? It's the original 4x4 of assumption, okay? And then you're solving for the next 1, 2, 3, 4x4, 110 being the last. But after this, okay, you gotta solve for the 5x5, I'm thinking. I have 712 here, and 7, like, I'm just trying to remember. This was kind of fresh in my mind a little bit ago. Alright, let's go move on to the next paper. Maybe it's here. Okay, so on this paper, I got a 4x4, a 4x4, a 5x5 centered on that, and then if you go the other way and center it there, there's a 5x5, but then if you go upwards and center it there, I choose to be here. Not the D, not the B position, but the capital P position, with the 11 in the middle and the 712 right here, because the 712 is your heptadecadon, with an interior angle of 158.28 degrees. It is a 17-noted shape, which is basically, if you have a 4x4 of 16 and a 4x4 of 16, two 16s side by side could be expressed as a circle 16, which could be a 17 from a different point of view. You understand by now how the circles work. So I said to myself, this is interesting because I have that number. Yeah, it's right here. It's 158 point 8.2. That's the interior angle of a 17-sided figure. Where's your seam? Here, I'll use this pen down here. It's better. Where's your seam? 1, 2, 3, 4. 1, 2, 3, 4. There's your seam. Now, I find that interesting. Two 16s, wherever on the other paper. Make a circle 16, make a 17. Interior angle of this 17 is kind of here. In the important lightning bolt spot. Anyway. Yeah. 110. Anyway, moving on. I'm looking at this thing. Oh yeah, yeah. So if you make a 5x5, okay, from the P position here, like I said, like I alluded to, There it is. Okay. It's not this one, and it's not this one. Okay. Why did I choose it here? Why did I choose that position? Well, because it's the only 5x5 you can make in the thing. So if you start a 5x5 here going this way and down, you fall off the reckoner. If you go this way and down, you fall off the reckoner. Only way I can is if I go like 2 from the bottom and 2 from the top. 1, 2, 3, 4, 5. So I chose this point to go that way, all the way to the edge, all the way up, and all the way over. And the thing is, things I find are very interesting with the next cells in this whole quadrant. Like 522 is just 174 times 3. 322 plus 26 plus I think the 3 for the C is 174 times 2. Or 322 and 100 is 522, which is again 174 times 3. So there's a 174 factor. So I'm looking at this quadrant. I change the paper. And I go like this. In this corner, you have a 712. This corner, you have the bottom 1,000 of the 3,000s that are in a row. Top, you have a 10. Other side, you have 7. And I'm looking at this. What's the sum? It's 1,700 and... Oh, with the 11 in the middle. I wanted to take the middle of the 5x5. Okay, sorry. So it comes out to 174 with a circle at the end, with a slash through it. Okay, 1,700, 2, 7 and 1, 10, 10, 10, another 10, 40. 1740. And the next cell beside it is 174 twice. Going off the reckoner. One in and one off. I find that really interesting. But, yeah. So the 17-sided figure means the seam is on the 9th column. So if you had one 9x9 reckoner and another 9x9 reckoner, the first of this one would be the 9th of the last one. 1991? I don't know. Yeah, anyway. Oh yeah, because a 4x4 would be like a 9, and that would be a 9. It's like a 9 and a 9, a P, a B, and a D. But I digress. I'm just farting along here. Oh yeah, and I was looking at the shapes, and it's like you need 1 plus 1. You don't need a third. But when you create a third, again, you have one segment is great. 1 and 1 makes a segment. We're cool with segments. Okay. When you introduce a third dot and then you make a segment, you actually have to make one to both. But when you do that, you create a new thing and then a three-dimensional sphere. The center of it being a singularity, and then the whole new structure being like, you know, a tetrahedron. Like, I don't know, whatever, how to draw it. And is represented by 1 and 1. Because you need a third to connect the shape to the singularity. The singularity and the shape. The shape's the diamond. Okay? And the singularity is your x. Your x is the point of the diamond. And this is your 3-leaf clover. Sorry, it's not 4-leaf, really. But it shows you that 1 and 1 doesn't quite make 3 because you need the 4th and the 5th. So it kind of has that whole kind of jive aspect to it. Oh yeah. And then, you know, capital P is 42. I don't know. Looking at numbers, and I was seeing 41 earlier, so 42 is, you know, the next one. Right. All right. So here's another interesting thing I found. I'm gonna draw this for you. Yeah, I'm gonna draw this one instead of showing you. So, what do I say a lot? I go, it's like 1 of 7 of 13 of 110. Of 2143. Yeah, that's pretty redundant. Okay. Well, what if I said it was this? It's a 1 of 7 of 13. Now, if we're in a 9x9 reckoner, okay, this is really going to be the circle. Sorry, I should have put the Anyways, if you have this in a circle, really, only thing you need to create this is a circle with a circle here, because it kind of makes two bubbles inside. Anyway, it'll create another one. Anyway, maybe there's four. Whatever. Maybe I should do a 1 of 1 of instead of that bubble. Let's just do a 1 of 1 of, and I did it backwards. Alright, let's try again. Alright. A 1 of 1 of 1, 2, 3, 4, 5, 6, 7. Look at me being accurate. 7. Now we know it's a 9 by 9, so we can only go over 9. Which means we have to go up 9, 10, 11, 12, 13. We got to go up here. So this would be a 1 of 1 of 7 of 13. Notice how it goes from a dot dot line to like an L. Plot thickens. So what happens if you go down 7? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You stop at the 10. So this value is a 10. No kidding, the one under it is 100. So this is a 1 of 1 of 7 of 13 of, wow, 110 of, oh wait, why isn't it, well, if you don't want to reuse the 10 and 100, how about we just use 255? That's also 110. Let's just, let's do that instead. 55, 55, that's 110 of, alright, where's the 2143s? Really, you know, that's the fun part, right? Well, look what's beside the 55 on the top. A 1, 11. Oh, wait, 2, 1 of 7 of 13. 2, 1 of 7 of 13. All right, let's draw that. Let's draw that. Let's draw 2, 1 of 7 of 13. All right, does that look like a 21, 4? 21, 40, 10, 11, 12, 13, 14. It's a 5. 21, 40. 21, 40. Oh, 7 and 6 is 13, maybe. Maybe let's make a little B or something. Let's go with that. 21, 40, 3. Circled, maybe. To put a period on the 2143. The end of it. What does that look like? It looks like the very beginning. Capital G. That's a 4 by 4. And now this would be a 7 by 9. Looking awful G-ish. I thought that was interesting. See, that's what this was. Booyah. A little embellished and stuff, but when I turned it around, I saw it right away. I was like, whoa. That's rather interesting. Oh yeah, this is interesting. Capital L. If that's the 12th letter and the 26th letter to make it a capital, it's actually a 38, but it's actually the Roman numeral for 50. But if you draw 50 correctly, it kind of looks like an 8 at the end. 3858. Find that to be interesting. 21, 43. Oh yeah, I found this to be interesting. Okay, like, remember, like, okay, this is like 1 of 1 of 7, 13, 110, 21, 43. Okay, well, it's, right, 1, 2, 3, 4, 5, 6, 7. 8, And these 4 things, maybe that's the 9th thing. Or is it 1, 2, 3, 4, 5, 6, 7, 8, 9 things? Because that's what we just did in the last G. We said 1, 2, 3, 4, 5, 6, 7, 8, like 7, 8, 9, whatever. I know what I did wrong. Okay, what did I do? Like 1, 2, 3. No, I can't count. That's 7. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, can't count right. So, and I was looking at this. 2143 is just bad C. And I find it interesting that our programming languages we use are C, C++, C++, Basic, Visual Basic. I want to call it bad C, because that would be 2143. But a good way to remember, pretty important shit for programmers. Instead of C++, call it bad C. That's all I wanted to say about that. Oh yeah, this is the greatest decode of life. I finally figured out U2 is just the 21st letter, but, 21, 43. Well, how do you get to 43? Well, if you circled the U, or had 2 U's, like a U beside a U, because it's suggesting U2, so 2 U's would be a circled U, which is a 21 by 1 by 21 line going around it, and if you choose the 21 and the 1, you get 42 in a bubble, which is 43. So U2 is 2143. Yeah. This is a long video. But those are the little things I got today. I really, really think, I'm going to think about it some more. That's interesting.